connection? Because
Here, hold on.
Hey, Jack.
Oh wait, what's the spark?
Trying to get wireless running?
Yeah.
Well,
Yeah.
we'll get the
There is
wireless
wireless in here, so if you have a laptop,
If
feel
you're
free
trying
to.
to tunnel into Sun's network, it's a little dicey because the routing is not set up properly.
Well, it should be difficult to tunnel into a network. You're not such a belief. Have you ever heard of network security, sir?
No, it should.
No.
Well, you see,
I'm sorry, I am the bastard operator from hell.
Okay, we do use IPsec and tunnels for our VPN, and it works from everywhere except from Sun Wireless.
and behind certain NAT configurations.
Well, and when more than one of us are behind the same NAT.
Yeah,
That's okay. I think that's one question.
because it is.
That's why I don't know. That's why we should go away.
Okay, so we're looking at 5 after.
Okay, it's up to you when you want to go. Let's see if there's anyone.
Are there any crowds trying to get through the door?
Who else was 42? Brian, get those dollars out.
Oh, it's really.
I won. 42. I'm not to make sure that Liane loses as well.
Yeah, I know.
Well, how many?
Very good.
How many is Liane betting on?
She's doing a lot.
Yeah.
She's doing what?
She's way over Brian's prediction before.
I get rid of the bag.
Liane said she has more mugs than we're going to be for. And she bought $5.
Okay. I guess we'll go ahead and start. So, probably feel we trickling in, but yeah.
Can you go around to the
What's that?
Can we go around to the
Yeah, we could do that.
That'd be
And where you're from?
Yeah. Let's go around. Brian is very skeptical of, first of all, that people would show up.
Yeah, if you can prove your identity.
And so he wants people to prove their identity and what, like where they work or how they found out about it. So, let's just kind of go around. We have, quite a few Sun people, but I know there's several non-Sun people here also.
Yeah, some people do this themselves too.
Yeah, absolutely. So you guys know. I mean, you guys might
and what you're
know.
responsible for.
And you guys might know some of the engineers that you read their blogs and stuff like that. Now you can meet them in person. So first of all, I'm Alan Duboff. Hey, Bob. I basically kind of am setting this user group up, and it's my intention that hopefully these user groups will basically set a precedence for people who are interested in Solaris and OpenSolaris, that they know that they can come here and get answers, and that Sun engineers will be here that they can talk to. And we have so much stuff changing in Solaris 10. Dan Price, who's here, has done several talks, and he has a slide that has all these pieces that went in that he doesn't even talk about in his presentation. And it's just like there's probably like 80 different pieces of technology that we put in that we don't even really talk about. So there's just a ton of wealth that's gone into 10, and a lot of people, most of you are probably using it. How many are not using it yet? Okay, maybe we'll convince you to use it. Maybe we'll see compelling reason. Anyways, let's do a quick presentation of yourself and go around the room so that Brian can see that there's non-Sun people here. Why don't you start, Alan?
Hi, I'm Alan Cooper-Smith. I work on the expert system for Solaris.
I'm Peter Osel. I'm not with Sun, so user of Solaris. I'm with Infineon Technologies, semiconductor manufacturer, best memory, all by Infineon directly, and responsible for maintaining research development environment in North America and for innovation worldwide.
Cool. I'm Don Calaroga, and I am on the global Sun, and currently just do that.
We get half a point for him, right?
Yeah, that's totally.
Michael Hunter, Sun Networking. Keith Stenning, non-Sun, Shutterfly.com.
Jonathan Adams, Sun. I work on SMF and Libbyman support.
I'm Dan Price. I work for Sun on zones and going to conferences.
Liane, Praza, SMF, and resource management.
I'm Brian Cantrell. I'm P-Trace and Praza. And I was actually skeptical that there would be not 5 Sons on the here, so I'm wrong. I lose.
I'm Mira. I'm with Sun with the MDE. I interface with Sun's IHVs and ISPs.
My name is DK Smith, and I just joined Sun again.
I'm Mike Cooper. I work with Sun, and I work on OpenSolaris.
I'm Wendy Coates. I work for Sun and work on selection.
I'm John, so I'm with Tefl in the UK engineering group. I'm Dan Duval. I also work for Sun, and I am the ON gatekeeper for whatever that means to on some folks.
Sorry for you.
Hadn't gotten that yet.
Henry Yen. I work in the Jest.C implementation. Jest is a peer-to-peer protocol, open source protocol developed by Sun.
Mike Guido, I also work in Juxta Group. I'm a Sun employee as well.
Mohammed Abdulaziz, I also work for Sun and I work on Juxta.
Mike Staley, I work for Adobe Systems, do directory services.
Gee, I guess I'm up next. Tex Woodworth, I'm a sysadmin contractor, also self-admitted bastard operator from hell, and holy Toledo, I have a start date. 29th, with the Postal Service!
Don't go postal on us.
They use Solaris.
Matt Kolka, Lucid Technologies.
I'm Wendy from Lucid Technologies.
Janelle Reynolds, California State University, Fresno.
Keith Wasilowski, I work for Sun on the OpenSolaris team.
Cliff McIntyre, I work with shopping.com.
Carla Arenas, also from Shopping.com.
Tom Trublett, Verizon Wireless.
James Todd,
Clark Smulders, Sun.
Tim Maslin, Sun.
Say what you do. And that's part 2.
I do kernel performance work.
Yeah, I work on things in Sun too, sometimes.
With image.
Yeah, I like it.
David O'Brien, AMD. Chris Baker, and I'm the product manager for Solaris for x86 and x64.
Ben Rockwood, I don't do much of anything.
Hey, turn the camera on.
There you go. Okay. So I'll let Jan take over. Jan, the first thing we're going to just have Jan show you guys the NewBoot architecture on x86 and x64. I thought that'd be cool. A lot of people were kind of waiting for that for a long time. And he can tell you all about it.
Okay, my name is Setje-Eilers. I work on Solaris Boot. And I'm basically I have no idea. This is a new group. I really don't know what interests you guys. So I figured I'd just start this by giving a demo, and then we can do some questions and answers. So, have you guys in general booted Solaris x86 in the past? Show of hands. Okay, good. So, it's nice to see it. It's very nice.
You've broken boot on x86 version.
So this is, if any of you have used Linux, or a modern Linux, I should say, you've probably seen this. So we co-opted Grub and used it as our early bootloader. And what this now looks like is really, and this is going to be a highly verbose boot, -v-m verbose, so you can actually see what's happening sort of in what amount of time. So we're going to return here. We're going to load something called a boot archive, and then boom, Sonos starts, and we're throwing up devices, and we're still throwing devices because there's way too many on this laptop.
Jan, do you want to use the mic there, or can everyone hear Jan?
This better?
No.
It's on. Okay. Takes time to get on. And takes time to do Solaris too. Okay, now we're well into system startup and things that don't really concern me. That's all Liane and Jonathan's problem. So, questions? Yes, now I'm back.
When was being a Solaris coming soon to me?
Yes, as soon as we can possibly get it to you. We're trying to very aggressively push this into an update release, and I actually don't know what I can say about this right now, but the target is update 2, and that's all the project teams knows right now, and we're trying as hard as possible to make that happen.
When is it expressed?
Yeah, when is it expressed? It is in 6:05, I think.
Assuming everything goes well.
Yes, assuming Danik doesn't have a problem with that.
Yeah.
Boot it non-verbose.
But does this get rid of?
Yeah, I can do it non-verbose. I have another machine.
Yeah. Can we have a show of hands? Is dark better than sunlight? Because I can't get it in between.
I think light is
dark
better.
It's kind of dark from my perspective.
Yeah.
Go for the reboot machine next to the NewBoot machine.
But I have NewBoot on here. I just put it on last night. All right, some old boot.
I've got an old crowd.
This is now non-verbose.
All right, hold on.
Are you going to do happy face?
This is mine.
We're going to see happy face.
I will see happy face.
Yeah, non-verbose.
That's happy face.
See all the messages not flying by? Yes.
What do you see as the main advantages for this booting system compared to the old x86 boot?
There we go.
Okay, so,
I know my machine's not booting. You answer the question.
You can plug it in, actually. Stop it, plug it in. Because this one just goes on. The next thing you'll eventually see is continue working. Just imagine that your head will leave switches over. What are the main advantages? So the goals were that we wanted to reduce our maintenance in system-specific hacks and bug fixes that we needed to do in order to work at all on a piece of architecture. And Grub is actually really great in that respect because it's been used by the Linux community. It's deployed on numerous machines that we can't really imagine even getting our hands on. One of the last things we did before we integrated the project into the current development tree is one of our engineers went to Praza Electronics with a DVD in hand and popped it into machines and did a reset button or power cycle them. And the only one that didn't boot was sort of the 499 special that didn't actually have enough memory. I dare you to do that with the old boot. Or actually, I don't dare you to do that with the old boot. It's going to be very disappointing. The other goals were to obviously get it out faster and isolate the operating system from the boot loader. So Grub is actually, the main attraction to me personally in Grub is actually that it gives you a clean specification and a multi-boot specification that you can write an operating system to and another bootloader if you want to. And you can develop them independently and they will continue to work with each other. Does that answer your question?
ACPI?
Oh, ACPI. Well, that's sort of a, yeah. So with us we brought something like 100,000 lines of code from Intel, which is ACPI-CA, and that's a whole new ACPI interpreter.
That works.
The old one works too. It's just not to the same spec as the new one, which is unfortunate.
But you got to get something out of the real mode drivers.
That gets some out of. There are no more. Yes, I forgot to mention that. There are no more real mode drivers. Real mode drivers are all dead. No more. This all uses the BIOS I/O operations to boot. So if a machine can boot from a device using the BIOS at all, we can boot. So if you have fiber channel firmware, that can boot. This works. So we can boot from fiber channel devices. Now, if you have firmware that can boot from USB devices, we can boot from that. However, if you have a SCSI adapter that has no option ROM, we can no longer boot from it. But that is mostly a thing of the past. Does that answer your question?
Yeah, thank you.
So if we gave you a 64 meg memory stick, could you make it boot?
I will attempt to do so during the install.
Okay.
So 64 meg is awfully small.
No, there's a trick there. I think there's a way around this, and maybe I can talk about another part of the architecture, which is that when we started this, Install came to me and said, we really need to be able to eject the CD we just booted off. And I said, well, that's kind of a problem because we have the UFS file system mounted on. And if you eject the media that your file system is on, just bad things happen. And what we did is we actually just sucked the entire media root into memory and mounted it in a RAM disk. And now that the CD is not even really required, and one of the hardest things for us to deal with actually is figure out where the hell it came from, because it came from the network, it came off the CD, all looks the same to us, and we sort of needed to go, well, how do we find the rest of the world again? But that means the actual image that the media root is now just a file, and it's about 44 megs, so I know I can fit it on there. And I'm going to see if I can't make that happen by the end of this session.
Is this a precursor to a live CD?
This is a precursor to a live CD. Absolutely. Actually the image that the media root image, we've certainly used it in-house to net boot machines to it and recode them when something went wrong. Our current prototype of the NewBoot project actually includes copying that media root onto your system. And then you can we offer it as a, I think you probably saw in some of these menus, there's an option that says Solaris failsafe. That's just a menu rooted into single user. And we probably need to do something around password protection and whatnot to make everyone happy there. But right now that's there. We'll see if it'll still be there when it goes out the door. But certainly the option to have it there will be there.
I think there's at least one community member and one Sun engineer working on live CD.
Yeah, actually, there were. I know the Sun project that was working on a live CD. The very first thing they actually tried to do. No, this is not the Sun project working on a live CD.
Yeah, there's a new one.
There's a new one. Okay.
Dave Miner.
Okay, no, Dave wouldn't have done this because he knew this was a RAM disk. But one of the first things somebody tried to do is actually package add 400 megs to the mini roots. And they can do that. Okay, fine. But now you need a machine with probably 500 or 600 megs to boot this. And that was not the intended effect. So if you want to do a live CD surrounding that, figure out how to mount another file system that's actually on the CD. And that should actually work fine.
So boot to the Grub prompt, and then I'll tell you when to go, and we'll do a boot off.
Okay.
I don't know how many people know how much it sucked before NewBoot.
So what NewBoot got rid of is basically this whole set of horrible timeouts and the ugly blue screen you used to see, which was the DCA, which loaded all of these real mode drivers, and it was awful.
Jordan Brown's dumbass changing.
It should also make working with other operating systems much nicer.
Are you using
Grub already knows how to boot Linux and other operating systems. So you can, I think multi-boot should be.
Yeah.
Can you talk at all about multi-booting other operating systems?
I will do that in a second, actually. I should get back to the rest of what ACPI-CA buys us. It actually buys us a fully featured ACPI interpreter and framework. And that will actually allow, that will gateway things. Right now we've been coming up with full utilities to twiddle the various functionality exposed through ACPI, like power off. Now, power off was something we were capable of getting to work with the old ACPI interpreter, but that was about the limit of what we could do without investing major work into it. And now we have battery status working. That took, I think, 3 engineers, 2 days of.
All right, hold on. So,
right,
wait for me. I've got to reboot again.
Don't use Happy Face.
Don't use Happy Face.
Use that one.
Use that one.
Use that one.
Right.
We'll have to see
Wait, don't hit enter. Okay.
What are you doing?
Okay, this is not.
They don't trust you.
Yeah, just put that.
Yeah. So this is non-verbose. And okay.
Yeah, non-verbose.
A regular.
All right. So I'll tell you when to hit the. Let me reset the BIOS here.
Okay, everybody focus on that screen. And this is what I am saving you from, and well, not just me, everyone I've been working with.
Did we just hear a gauntlet being thrown down?
No. This is not a gauntlet. This is more of just a demonstration. I know how much. All right, and hold on. Go.
Right, I'm at the Sunhouse Lover. How about you?
I'm learning about something called configuration assistant.
Okay, how's that going for you?
All right. I haven't forgotten the second. I'm now at the second 5-second time.
So for those who haven't used Solaris 10, this is kind of another interesting.
Oh, hey, wait, I'm going to catch up.
Type real fast, you might still beat him.
Are you typing blind?
Oh, no one.
Oh.
Your boot archive surface.
Yeah, just
the tortoise and the hare. Da-da-da, my hosting. Here I come. We got hosting.
Medium's clear.
I can't see it.
Oh, that was the user! Booyah, NewBoot!
No.
Just boot that.
All we said was boot. We didn't say multi-user.
No.
D-O-O-T. Flash.
Well, this is a great segue to your talk.
Liane will now educate us.
Okay, I have no screen. I'm typing with the query mark.
What's the service? You got to control off screen.
It is boot archive. I think it's all the backspaces that he did.
Probably.
That shouldn't have been, though.
Yeah.
I'm typing on a German keyboard with no screen, and that's not going well.
Wait,
I apologize for that. So actually, what you see here, this failure mode,
We have a long history of demos showing you supposed to be bad.
There's a,
Don't go back.
so one thing that's actually involved in NewBoot, and one reason we can actually bring it out quite so fast, is all of the various files that were needed during boot, because Solaris is not a monolithic kernel, which means we don't compile everything in that we need into one single blob. Now we're actually wrapping that up into a single archive that we load. And this represents sort of a problem that we need to keep that archive in sync with what's on your process. So if you add a bunch of drivers, those need to actually go, and if those drivers are required during boot, those need to go into the boot archive. So we have some frameworks surrounding keeping that archive in sync. And what you saw here was new power cycle on that machine while it's running. And the boot archive not being in sync. And in fact, this machine is actually running some older bits, and this is where you learn that you probably shouldn't bring your volume bits from 3 weeks ago to a demo. And the check was somewhat overly aggressive and told me that, oh, my life is not absolutely perfect. You should probably go do something about that. So any questions around that?
We'll talk about how to troubleshoot these problems in the next presentation.
Yeah, I was going to say, and if there are no questions on that, actually, any other questions? And if not, okay?
So, a couple of quick observations. Talking about memory, with NewBoot, we'll be raising the minimum required memory to 256 megabytes from the current 128, I believe.
That is correct. Now, the minimum memory requirements, and I would like to actually just say it's gone up to 256. If you don't have 256 megs in your memory in your machine, you're obviously not serious about doing anything with it. But
Beyond the latest SUSE I saw was on somebody's desk, and I went flipping through it. You know, it's like the CD pack. They're up to 256 also.
yeah, the only reason Microsoft is not up to that is that they haven't been able to release an operating system in the last couple of years. But that said, if you have if you're an OS collector and for some reason love inflicting pain upon yourself, the only thing you can't do with less than 256 megs of memory is boot the MIDI root, which is, as I explained, the entire MIDI root in memory. You can still use things like live upgrade, or you can CPIO up an image of the machine, you can splat it down.
Not booting the MIDI root means you can't install.
Right. And so you can't fresh install or upgrade off of the CD. You can, however, use live upgrade. Somebody's already.
Take the call. Take the call.
Sorry about that. Yes, Bart?
So for an embedded system, is that also true there?
Yeah. It depends on how you design the embedded system. Because in an embedded system, would you run the installer? No? Okay, then your minimum memory is somewhere around 80 megs. Okay. Yes?
One more observation. We made Solaris somewhat more multi-boot friendly by changing the partition identifier, so we no longer look like a Linux swap partition.
Yeah, that's in Solaris 10 though. That doesn't require
So
NewBoot.
it's a generic Solaris 10 thing, but I
Yeah.
just wanted to make the audience aware.
Actually, that reminds me though. There's something else I should mention. There are people who used to multi-boot or who want to multi-boot their machines with Solaris on it. That is not use the multi-boot spec, but use multiple operating systems on the same machine, not at the same time. They've sort of come to really love the x86 boot partition that we kind of wanted you to use in the past. NewBoot completely, utterly obsoletes that. There are a couple upgrade scenarios in which we haven't been able to entirely get rid of it, but if you're fresh installing a machine, or even if you're upgrading a machine, you try really hard to get rid of it. Fresh install will never ever bump that down again. And that should actually help free up a primary partition and silence some angry cries we've been hearing about that. Yes?
What was that ACPI standard you mentioned?
It's not actually an ACPI standard. It's ACPI CA. It's a free implementation that Intel came up with, primarily to sort of try to get the various non-Microsoft OSs standardized on an implementation. Now, that said, it's really just the interpreter. What we then do with it is up to us. And we do have some projects staffing up surrounding that now. So I know we had some tadpole people here before, or at least one person, and I'll get you my business card because we need to get your people in touch with my people.
Over lunch.
Yes. Any other questions, or are we ready for us on that?
How about we take a break for drinks?
Beer?
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 So,
I don't think there's beer. There's nothing alcoholic.
Beer?
All right, so thank you.
Got plenty of drinks. I'll start in a second.
There you go. You win. You win everything. You win it all.
And availability problems. Compatibility is an important part of SMF, and what changes you can expect if you haven't run Solaris 10 yet. Components, commands, what we do with restarters and services. Finally, a more interesting part, troubleshooting and repair, where to start when things go wrong, as well as some service development notes. And I've got some specific OpenSolaris content at the end here. First of all, terms and definitions. So what is a service? It's relatively highly overloaded term, so we actually want to develop it, to define it precisely on Solaris. The idea is it's long-lived. It's got well-defined state. You know if it's running or if it's not running. It's not a question of whether you're serving web server pages. It's actually, you know that it is running at that time. It's got relationships to other services. You know you need to have network and name services running before you actually start up Apache because it's not very interesting without that. Usually it's critical to operation of the actual system or business objectives of that system. So service management is even a little more tricky because there's a number of different things we talk about with service management. One is the developer perspective of service delivery. How do I actually manage to deliver a service on a Solaris system? The second one is administrative interaction, which is what most people think of when they're talking about service management. This is, can I enable the service? How do I restart it? How do I make sure how do I find out what its configuration is? And then the last part is management of the service by the system, which is actually interesting and part of our predictive health self-healing strategy. How does the system take a look at the service in order to make sure that it's providing service up and running and what it looks like? Thus, those were our goals when we actually created the service management facility. This is all part, as I mentioned, of the predictive self-healing strategy, which is right now a merging of the Solaris Fault Manager and something our marketing department calls the Solaris Service Manager, which is also a service management facility, or SMF, just to not be confusing. The Fault Manager is right now the part that actually takes care of the diagnosis of actual hardware faults, figures out what's going wrong with your system, tries to repair them if it figures out it's already gone wrong, or proactively retire components when they're detected to be likely to be faulty. Along with that there's a bunch of precise administrative messaging and syslog and actual diagnosis of what the faults are on your system as opposed to what the errors are that you're seeing. So SMF partners with the fault manager to basically make the services self-healing. While the fault manager can take care of your faulty CPU or your failing memory and retire it out of commission, still the memory that you couldn't get access to is propagated up to your service, and your service may crash because there is an uncorrectable memory error. So hardware faults used to cause system restart because we didn't know where things went wrong in the system. We didn't know how that corrupted piece of memory affected other applications on the system. With the service manager, we can isolate the faults to the affected services. We actually know which service had the fault. And then additionally, we can restart the software in the face of hardware or software faults. And this actually includes administrative error and software faults such as core dumps and the like. Some of the features. In the area of administration, I'm going to do a couple demos here. But the first thing we wanted to do is make the service a first-class operating system object. Usually, the operating system sees software services as just a set of processes. It doesn't really know how they're related aside from some weak parent-child stuff that daemons usually circumvent anyways. So how do I actually know that those two processes are similar? The operating system in the past didn't. It didn't care. It didn't know how they were related. But actually, when you're using these services, you care a great deal. So what you actually want to do is manage services, not processes on the system. And this is what we used to do with the init script, but there wasn't a clear boundary. You couldn't tell that this init script started up these three processes, and those actually constitute the service that the init script was providing. The next thing is our easy access to misconfigured or misbehaving services. We wanted one-stop shopping for things that went wrong on your system. So you could actually tell what's going on, what's not working that I expect to be working. And we can actually, now that we've got that one-stop shopping, improve error diagnosis over time. Supported enable disable is a really big thing for us. Many people actually don't know that, for example, if you disable the sendmail service by removing its init script, when you would patch the system or upgrade the system again, suddenly it would be enabled again because the patch would replace the init script where it used to be before, and it would get started and you would notice it, and later on you have to go disable it again by removing the init script. With SMF, we preserve the administrative intent. We know that the administrator typed service atom enable, service atom disable, and we can preserve that behavior across patches. We want to securely delegate tasks to non-root users. Basically allow you to say, this person has the ability to administer Apache, and Apache only. They're not allowed to change my Oracle database or muck with my file systems or anything like that. But they're the Apache administrator. I trust them to actually restart Apache. Boot messages become under the control of the administrator as opposed to the whim of the shell scripter who happens to write the init script that you're interacting with. And we actually expect more features in that area in the future, where you'll be able to. Right now, there's basically a quiet boot, which gives nearly no messages. And then there's a verbose boot, which looks kind of like what you might expect from Red Hat, which is essentially, you saw with John's demo, a service-by-service listing of what's coming up. And finally, more reliable console access. If any of you actually run NIST, you may have noticed that when your NIST server goes down, your Solaris 9, your Solaris 8 system would just sit there and hang, waiting for NIST server. And it would hang, and it would hang. And if you hadn't been smart enough to boot with KDB, you got to actually stop A or unplug your system in order to boot -S and figure out what was going on. So lately we've been actually changing our IP addresses around Sun. And so I got a call this Monday morning and said, hey, my system isn't up. Network service is failing. And so we debugged this point. It's like, oh, your IP address was supposed to change. Your subnet was actually wrong. You've moved on to a new subnet. And network service wasn't coming up because NIST isn't coming up. Now, we can do better on our diagnosis there, but on the other hand, you could log in, figure out what was going on, which is a huge step forward from where we were before. So a couple examples of what we're actually doing here. So when I talk about services as a first-class object, the services command basically allows us to just list out what the services on the system are. It's a long list. We did about 120 service conversions over the course of Solaris 10. But what you see is essentially the state. The last time the state changed, so most of the things are online on my system, and I'm going to pick on SendMail in a moment here. But some other interesting points are the legacy run services, which start at the top here. These are the init scripts that still stick around. We can tell you when they started. We can't tell you when they restarted because we don't have the tie together that we have with SML. But we can actually tell you when they started and what they are. So the next thing, as I was talking about, now you can actually tell the processes associated with each service. This isn't a very good demo except for SendMail here, which I like to pick on, which actually has two processes associated with it. And it's SMF that understands how these processes are related. So the next thing I can go ahead and do is I'll grab my root shell. Administrative error, imagine if I actually fat-fingered something I meant to do. And you basically see that within a second, SendMail has restarted, it's got new PIDs, and basically no problems at all. We detected the administrative error, we killed it externally, and that could actually also happen to SendMail before dump or any of those things like that. So what you might say is, well, actually, I meant to kill SendMail because I wanted to do some administration on it. Okay. And that basically stops SendMail from running. Just go ahead and disable. So if I go ahead and do it, I see that there are no processes, and it's disabled since that time. So the next thing is I was talking about easy access to what's wrong with my system. So let's go ahead and do this. SendMail starts with just a startup script like it used to. It lives in the service method. And so SMTP SendMail. So what happens if I go ahead and I move this thing aside so that SMF can't find out how to start it anymore? All right, now I go ahead and I enable SendMail. So I could type. And the same thing, we actually see the services and maintenance. Something's gone wrong with it, and we didn't know what's going on. There are no processes associated, so what's going on? I type the simple services-x command, and it tells me something about SendMail. So what does it tell me? Well, it's in maintenance state since this time. What's the reason? The start method failed repeatedly. This URL basically gives a website with more information about the failure, which we can actually dynamically update on the fly, so you don't have to have your system hacked in order to get the latest information. But the most interesting part here is I can go ahead and I can take a look at my SendMail log for more information about what happened. So what's going on? Actually, pretty darn obvious here. Lib service method, SMTP SendMail, not found. Method start, exited with status 1. Pretty easy to actually see what's going on. Now, obviously, all of our diagnosis for software isn't, the best it could be right now. But this offers us an incredible framework, an incredibly powerful framework to actually start diagnosing our software failures more and more granularly. So what do I do when I want to repair it? I just move that X. I'm not in the right place. And I go service item clear to tell the system I repaired it. And it's online. The other final point is I talked about delegated administration. One thing that I've given myself on this system, because I trust myself to enable and disable services on my own laptop, is I actually added myself to the user adder database with these new authorizations, the Solaris SMF Manage and the Solaris SMF Modify, which allows me to both enable and disable services as well as change their configuration. So I also can do on this system, and it's on its way down. Now disabled. So we already talked about some of these self-healing services. I showed you how services can automatically restart if there's an administrative error, such as killing off your service. A software bug, so if your service core dumps, it will automatically be restarted. And the uncorrectable hardware error that we talked about before that would be detected by our FMA system, and the Solaris would keep running, but your application would go down because we just wouldn't know what was in that memory that we needed to recover. Automatic service snapshots and repository backups are something that we actually get from our SMF repository. What we have is we can actually look at the last time this service started successfully, before I made a bunch of changes and completely screwed it up, and revert to that snapshot with essentially no administrative hassle. You can undo changes in this way, as well as recover from backup. We take automated backup repositories in case it becomes corrupt. And if your repository does become corrupt, we print an error to the string that tells you essentially how you go back to one of those recovery repositories. What falls out of our dependency mechanism is parallel startup. You can essentially start out a bunch of services at the same time because we know their dependencies are satisfied. So one of the things that we really get is on our bigger systems, our multi-threaded systems, our multi-core systems, they boot a lot faster. You don't really see this on the single processor system because we're I/O bound on these slow disks that come with your laptop. But the larger systems are booting faster and faster with SMF, and you can imagine that if your applications can start up in parallel, if you start them with SMF, they'll actually be started. They'll be started in parallel, so your system will boot faster because your Oracle and your app server can start up at the same time if they don't have dependencies on each other. Legacy mechanism also still work. You can still deliver in an init script so that there's actually not a required change for people over from previous Solaris releases or other Unix OSs they use. Finally, a number of features for developers. We want to unify service delivery across a number of different mechanisms, provide a standard way to deliver a service with Solaris in a way that Solaris can understand. There's a minimal impact to administrators. And I'll show an XML snippet later that describes exactly what's necessary to develop service. We've got a single API for management, configuration, and observation, which is incredibly huge. So now that we have this single API, it's really easy to write tools on top of SMF to query all your service, enable, disable any service. You don't actually need to know the specifics of the service involved to write applications on top of it. What's really cool is I've now seen about 5 different GUI demos that fell out of this pretty quickly. Webmin already supports SMF. It's got a cool little SMF panel that I mentioned on my blog. And as well as there's a number of different GUI demos that are going around. Eventually we'll do our own GUI as well, but it's really nice to know that it's easy to develop these. Service-based resource management was also important to us, allow us to essentially tie the Solaris resource management features to actual services instead of users or groups or projects, which is usually not the point at which you administer an actual service. You don't want to have to map always to the same user. You actually want to be able to bind a service to a specific resource management entity, such as a pool or a resource control and the like. And last, this was kind of for us, but simplify debugging of the boot process. Every single Solaris release, we basically used to break the boot order of Solaris because there were all these implicit dependencies in our RC scripts. We didn't understand how they were related, and people started up as daemons in the background, and so when Solaris got a little bit faster, some of the RC scripts would start failing because their dependencies required on them being started, and that ampersand, suddenly Solaris just started the daemon that much quicker. So this was really important to actually figure out what was going on from Solaris release to Solaris release, as well as develop some stable points of control. So as I said before, System 5 init scripts just work. There are 2 minor caveats which don't hit most people, and we're happy to work with anybody that they do. First of all, if they rely on being run before a specific Solaris provided script, so that if, for example, you were interposing yourself before the root file system was mounted, you have to convert so that we can have a dependency on you and know that we need it started for your service. Or if there's required input from the console, because in order to do those service log files that I showed, we're redirecting the console input and output. So essentially, there's just a small redirect dev console link that needs to be changed in the actual script itself. Legacy services are visible in SMF to provide a little bit of extra administrative information. Our documented init.p scripts still work. If you used to use NFS server, NFS client, NFS server or send mail, start and stop, those just work. You can still run the scripts, and we re-implemented them using SMF underneath. They're about 3 lines now rather than 60 or whatever they were before. Init tab still works. And we haven't absorbed any public configuration files except for inetd.conf, which is no longer a primary configuration source, but is used as a compatibility configuration source. So basically, we take all the entries in inetd.conf for Solaris, we converted them to SMF. But if you've got any ones still lying around there on upgrade, they're actually converted into SMF services using this inetconf thing. Also, inetconf can be run by hand after any package out of the like in order to convert those entries manually, which is also a really, really useful development tool. We also print warning messages if anything happens during boot as far as unconverted services. We can detect them, but we don't want to auto-convert them without the administrator's interaction. Boot is quieter by default. You actually saw this with the demo earlier, but that snippet at the top is essentially what my test box looks like when they're booting. It's a lot quieter. But the good news is all that extra information, and we've even added more information about what's going on, is going to log files. So there's no longer a question of, well, do you have a picture of the console? Do you have a tip line, something that we can actually use to scroll back and figure out what happened? No longer are those messages actually scrolling off your screen. Verbose boot is also available, like I said before. It looks kind of like Red Hat. Basically, we just say, here's a service, and it's starting, and here's a description of the service. This is what the service actually does. As I showed before, processors are essentially like the waking dead now. They refuse to die. They keep popping back up after you kill them and kill them and kill them again. So you can use Service Atom to actually tell the machine, no, I really want those to stay dead. I don't want the system to restart them for me. In addition, the init.dnrc directories are incredibly empty now, which is a nice thing. And they will only be getting emptier as time progresses with Solaris. This is an eye chart, essentially. There's a bunch of components to SMF, and essentially what this shows is that there is a kernel component to SMF, which I'll talk about in a few slides, and that's contrast, and that's how we actually detect processes are going down. And it's still around. It still retains all of its capabilities as a zombie reaper and the like, but most of its startup capabilities are given to service.start in Solaris 10. Config is a repository daemon on top of which our commands, our observability and management agents are actually built. In addition, there are inet services, which are still managed by inetDL, although somewhat differently. In addition, there are services which can be started by startd. This delegated restarter thing I'll talk about in a few slides. So what does a service actually look like on Solaris? So it is our consistent specification of a software object. It's stored in the SMF repository. The service manifest, which we'll talk about in a moment, is a delivery mechanism. The actual configuration store is a database on the system. The properties of the service are divided into property groups. These are transactional boundaries. Essentially, you've got your name, description, and doc references, which is really cool. No longer do you get to wonder what does that daemon actually implement, because there's actually man page references which go along with each of these services, so you can figure out how to debug it, how to fix it, and what it might be actually used for. Dependencies are an obvious thing. What does the service require? As well as service-specific startup properties and the like. Service instance is a running view of the actual service. So we use the term service in SMF a lot as a shorthand for what's really a service instance. This is the thing that runs on your system. So why do we have the distinction between a service and instance? Well, the service collects configuration. It allows us to inherit configuration across a bunch of different running instances. So a really obvious example is a web server. Your web server, you share a bunch of common configuration, except you want them running on different ports with different root directories. Those would be implemented as different instances of the service where you can still inherit a lot of configuration from a single place. The service also has a well-defined state, and this is the full and complete list of states of an SNF service on any system, which is a nice thing because that's an interface you can count on to go ahead and look at what the service is actually doing. Uninitialized essentially means that SMF has noticed it, but its restarter has not decided to do anything with it. Its restarter may not be started, or we just may not have time to get started with it. Offline means it wants to be running, but it's not running yet, essentially. Perhaps its dependencies aren't satisfied, or it's restarting. Online is the obvious. It's running, it's healthy. Degraded we've saved so that when we eventually enhance the SMF facility with the ability to more carefully monitor applications for health, they can be moved into the degraded state, which means they're working, but maybe they're slow, maybe they're only partially working, and SMF isn't going to restart them yet, but it's to let the administrator know that things aren't all okay. Disabled is pretty obvious. It's not running, it's not going to be run. And maintenance means there's something wrong that SMF couldn't figure out what to do. It's going to hang out there until the administrator interacts with it, and that's where services-x gets involved. Non-persistent property groups are basically, we can actually also store things that only stick around until the next boot, so that when you reboot, a lot of this temporary state can be, is essentially flushed. And they're named by these things called fMRIs. You've actually seen the examples of this already when I was typing the services command, but the the fMRI is a fault managed resource identifier, which is a namespace we share with FMA, which is indicative of a lot of things. It means that we're going to be pursuing a lot more integration as time goes on. The category in the service is, let's see, the category is essentially, oh dear. The category is essentially a useful administrative handle. It's in the network category, it's in the application category, the system category. It's essentially, what does this thing basically do? The service name is the thing that comes before the colon, the SMTP in this case. And this is an example of where you might want to, where you can actually share some information about configuration, or more specifically, share a dependency. Dependency sharing is actually really interesting. You probably don't care if your SMTP service is being provided by SendMail or Postfix or QMail or anything else. What you care is that SMTP is being provided on the system. So you can specify a dependency on the actual SMTP service to say that SMTP is running, and I don't really care which flavor of SMTP server is being run. In this case, the instance, the SMTP server would be SendMail. Our property groups and properties can be actually specified with the fMRI too, but that's syntactic sugar that's not often used. All of our commands do take abbreviations, essentially. It kind of looks like logging, and it uses the fnmatch functionality, which you take a look at on our man pages. But instead of typing service:network/SMTP:sendmail, you can actually just type services sendmail, as I showed before. Shell blogging is also supported, but do remember to escape your meta characters such as star, which is an often seen error for us. A service manifest is how you deliver the service onto the system. Basically, you make all this XML goo, and then the system, during boot, imports that XML goo into the repository, where it is a service that can be started and stopped. We do ignore them once imported. It's basically so you don't have to deliver some crazy binary thing along with your package. You actually can just deliver something that's readable by humans. So what does this actually look like? So this is always scary. I should probably split this up into 2 slides. Everything that's in this lighter purple below, starting with stability level, is optional. So what we basically got is about 15 lines here of XML that's required, and this is what it looks like on your Solaris system. You can go look. You can actually go look at the UTemp service, and this is really what we did. That it's relatively short. I know it's, and I'll actually come back to all the constituent components in a bit, but basically the service name is system UTemp. I'll talk about some of the stuff in the middle. You've got dependencies, and you've got methods, and that's it. The stuff at the bottom is the nice stuff that we can actually do as far as creating a common name that's also localizable, so you can have a translated name in different locales, as well as man page references for the things that are less obvious. The service profiles are pretty darn cool. It's one of the big reasons that we actually wanted to do SMF, because they provide the ability to turn off and on just bundles of services at a time. So what they are is a pile of XML, a small amount of XML that live in var service profile. What they are is they just say, I want this service enabled. I want this service disabled. And that's it, over and over and over again. So you can customize with this var service profile site.xml. But what we provide for you is this, and forgive my messy laptop, this generic limited net profile, which is essentially, as I said, a bunch of enabled and disabled. Yeah, the system key map is enabled. Okay, who cares? What you do care about, tell them all of those horrible, awful plain text services that are provided on the network are all the plain text services provided on the network essentially are disabled in this. We leave NFS running and the like, but it's a somewhat more secure system out of the box. And all you need to do in order to apply this is type service config apply generic limited net. And that's basically all you need to type in order to apply this to your system and have a more secure system. Obviously, you can also customize your own, and we suggest doing this with the site.xml file, because that's essentially where it's always applied last. We will never, ever overwrite it on your system. It's your site customizations and the ones that stick around for posterity, no matter what profiles are applied before it. There's a man page reference for some more detail on how to actually use it.
you would anticipate people edit this by hand?
For right now, yes.
Do you have decent error messages for the inevitable time when you get the wrong quotation mark and so on?
They're not so great right now, and they're getting better. One of the things is that we're working on right now there's a developer introduction on our Big Admin site. What we're working on right now is the developer guide, the entire document that actually shows how these things are easier to use. One of the other things we're working on in some of our spare time is essentially something to guide you through the process of creating this XML, so you don't have to create it by hand.
But mention that it's validated.
It is validated, and XML when it works. There's a DTD, all the standard stuff. In case people don't know, that's Tim Bray in the back, so he's holding me to task for my XML here. I promised luminaries in my blog, and that's definitely one of them. Legacy services. Essentially, we start in Stockholm like we always have. No differences there. Faults aren't handled by SMF, though. You need to tell SMF about your service and its dependencies in order to allow us to restart it. Basically, def is what happens. Creating these basically 15 lines of XML allow the system to know a lot more about your service so that we can restart it when there are failures. Services does show you the script names with basically some minor syntactic changes, and we prefix them with LRC. And I mentioned about the start times and the like. Security we did a number of different things. First of all, disabling services actually happens to be a huge thing for security. Just knowing that you can disable something and it stays disabled is a long way towards making your system a lot more secure. The profiles we already talked about, generic limited net is already provided today. We're going to provide more in the future, and we're also hoping to make these visible through install. So you can basically say, I want to install a lockdown system or a web server system or the like. SMF actually allows you to do this relatively easily. And these profiles also, by the way, can be placed during your jumpstart install. You just put that site.xml into place, and the next time it reboots, so after it's installed and rebooted, we'll just start we'll apply all of those profile rules so that your service is configured with your system is configured with all the services enabled and disabled that you want. The next thing we did is I already talked about modify and manage our authorizations to allow you to manage and configure services. In addition, there's this method context which can allow you which allows you to take care of what I talked about before, which is a service-specific enable and disable authorizations, essentially. And there's a really great white paper that's about to come out on this from Glenn Burnett. So stay tuned to the developer.sun.com/developers, and I'll also link to it from my blog because it's good. The repository is, like I said, it is where we store all our configuration. The reason we actually use a repository, that is to say a database at backend, is because we wanted transactions. That's one of the biggest things we wanted from this. Transactions allow us to actually be robust in the case of failures, and I'll show you a couple of slides. I'll show you in a few slides a diagram that shows how we can be, why we need this robustness in our system. It isn't intended to be a giant registry. It actually has a schema that is geared towards services and instances. Obviously, this can't stop us. This isn't going to stop people from using it as a giant registry if they want to, but it hasn't been used that way thus far. It can contain simple configurations. So that is to say, if you were writing a huge parser for your service in order to just have a .conf file with 3 lines in it, it's really easy to actually move this into SMF, which is all manipulatable with simple shell scripts. Because you no longer actually have to parse whether the configuration is valid or anything. Service.config is our single point of access to the repository. And this is what allows us to actually implement that one API to the repository, and also allows us to change its implementation in the back without actually affecting the API. Contracts are cool. Contracts are essentially a way to express relationships between a process and some kernel-managed resource. In the case of a process contract, which is what we use for SMF, the kernel-managed resource is a bunch of processes, essentially. On the other hand, there may be other contract types in the future. Essentially what you can do is say, I'm interested in events which happen on this set of processes, and I'm responsible for handling those events. In our case, we restart the service when they happen. Contracts are a generic feature in Solaris and can be used to create your own kind of little restarters for your application services and the like too. StartD has two components, two big responsibilities. One is a graph engine, which is essentially, it talks about all the dependencies on the system. Pretty simple stuff. It essentially knows these are how these services are related to each other. And then when it receives information about state change of the service, it sends that information, it sends requests off to a restarter which says, okay, so this service has changed, and I know that, service A depends on service B. And now that service B has started, tell the restarter, okay, service A is ready to start. Run level management moves into StartD, which is a NIT. The restarter is the one who's responsible for actually taking care of contract events, noticing that a service has failed, as well as generally managing the service's environment, bindings, and the like. A delegated restarter, which is something that's a private API right now, but we're looking to make public in the future, takes responsibility over for executing a set of services. Basically, it can have its own fault model that isn't the standard fork exact fault model. For example, you could imagine that there may be specific information around Java services, which isn't just restart a process or two, but actually a little more granular than that. Clusters actually will also use this functionality. inetd, one of the things that we provide with inetd is to have functionality that's common to a bunch of services, bind to a port, the standard stuff that inetd does. So inetd is implemented as a delegated restarter for inet services. In addition, we also enhanced inetd in Solaris 10 in order to be more feature compliant with what xinetd and the like does. TCP wrappers, max connection rate, all those standard things, which some of the nice things that XMPP does are also now in Solaris 10. And it's not very interesting. It loses a bunch of its responsibilities, which is good. There's some really crafty stuff in there. And I'm going to cruise relatively quickly through our commands because I demoed a bunch of them before. In general, services where you start for information about the system and information about a specific service. Services-X is definitely the right place to start with what's wrong with my system. Service admin is how you start, stop, restart services. Service config is essentially a Swiss Army knife for property manipulation on your system. It's how you access the repository in a complex way and get access to all of its features. Service prop is a lot simpler, and you can essentially do simple property reporting. This is really useful for things like scripting, where you can enable and disable, where you can check what the state of a service is relatively easily. We also introduced inet management commands, inet ADM, so you can look at just your inetd services, as well as modify specific things in that are basically specific to inetd. Inetconf we also already talked about, which converts inetd.conf entries easily into SMF. This is relatively a reference slide where the contract subsystem also introduces its whole set of commands. CT-run is how you can execute your own little restarter. CT-stat to display some contracts. CT-watch to monitor their events. And you can also use CT-stat to kind of watch what's going on in your system, as well as contract APIs and the file system. Services. Pretty easy stuff. -A tells you all instances where with no options, you actually just get the ones that are enabled on your system. They're sorted by state and time, so when you get the display, the stuff at the bottom is most useful to you. It's stuff in the weird state. -X is the most useful option to it completely because it tells you what's wrong with your system. You can look at dependencies and dependents, show processes, and -L for long or verbose information. Service atom, enable, disable, refresh, or restart. You can also synchronously wait for changes with services with -S option, which is really useful for shell scripting to basically say, I want to enable this and wait for it to come online. So essentially what these actions mean, enable means start once the dependencies are satisfied. Even though you've enabled this thing now, it won't necessarily start until its dependencies are there. Disable means completely disable. -T is useful because it actually does enable until the system is rebooted, which allows you to do some temporary maintenance on the system. -S is synchronous. Refresh is to reload the service configuration and run a refresh method if necessary. So this is standard syslog.com stuff. So you just be able to, or you still can send a hop to syslog to have it reread syslog.com. You can still do that, and the refresh makes that common. You don't actually have to implement hop. It may be done in a different way with your service. Restart is essentially stop and then allow it to start once its dependencies are satisfied. Yeah, question?
Do disable, does disable cascade, like if there's other services that have dependency on it?
Yes, so if they basically are specified such that they need to shut down, if your service is then disabled, then they will also be shut down.
But they won't be disabled.
Yes, correct.
Okay.
We do have a recursive enable, which will enable anything below you, essentially. So all the things I depend upon should be disabled, but we actually haven't done it up the tree that anything depends upon you will be enabled. Milestone, still need to update this slide. Milestones, essentially, you don't need them. For the most part, they're just not necessary. Most people do their system administration with boot-s. Continue doing that. There's no need to switch to these milestones, which we use as an implementation mechanism for the limited run levels. However, they're there, and the really useful one is boot-m milestone equals none, which essentially means don't start up anything, and which is really useful when trying to debug service problems, because essentially what you can do is do a boot-m milestone equals none, and then when you get to the prompt, type service atom milestone all, and then there you get a login prompt from which you can watch services starting up, which is kind of cool and fun to do. Service config, again, it's our Swiss Army knife. Essentially, you can list properties, as well as the edit prop command gives you an editor that allows you to directly edit the properties, and then they're committed on exit. And again, the refresh and restart is to load that service configuration and then restart with the change config. Service prop allows scripting and is what should be scripted from instead of the services output, which is unstable and can change as we find that as we find more useful ways to display the information. Service prop won't change. You can count on that being there from release to release. iNet atom is one thing that's interesting is now what we can do is write a bunch of administrative commands which are specific to the services that are actually being that are being administered. Service atom is a generic tool. It doesn't care what your service is or what it does or how it might be configured. It has no actual syntactic information about your service. However, iNet ADM does have information about iNet services. So when you do a -L with the -L on the FTP service, you actually see a whole pile of specific iNet properties, and those can be easily overridden or changed. So I still wish, what I should do is I should at some point comes up another laptop to do this demo well. What's really fun is on a Solaris 10 system, I don't suggest doing this on a system that's heavily used or anything, but you can go off and do kill-9-1, which basically means kill off all of user land right now today. What happens is, I'm guaranteed for you, and it will restart. By the way, that's new functionality in Solaris 10, and it couldn't restart sanely before because it stored a lot of its information in its memory and not anywhere where it would recover it when it restarted. Service.startDate will restart, and it will pick up all the information about what state all the services it was dealing with were in, which will in turn restart service.config and inetd. So the reason we needed this transactional database is because it could die at any point in time. Any of these components can die at any point in time, which means that transactions need to be committed to the database to know where we can pick up the information from. So then finally, all the services start getting restarted as appropriate by their restarter, which is kind of fun to do. It's not perfect yet, but it's getting better and better. And there are some places where I know there are troubles, such as the auto mounter. It doesn't get along with what its kernel state is and the like. So how do you define service relationships? Basically, they are restart relationships, and there are a number of different types you might have. Require all is the most common type. Essentially, all of these services are required in order for my service to start. Require any is at least one service is running on my system. At least one of these services is running on my system. So this is For example, if you needed IPv4 and IPv6, either of them running would be okay with you. You can use require any. Optional means that if it's here and it's running successfully, I need it in order to start. And include isn't commonly used, but essentially it allows you to say if this service is running, my service should not be. Restart on says the failure characteristics. Essentially, most dependencies are required only for startup. However, some of them actually should require a restart of the service. So error says if there's a hardware or software failure. Restart means that the dependency restarts for any reason at all. A refresh means stop, just restart it, or refresh, which is pretty darn violent. It means that the configuration changed at all, the dependent service needs to be restarted. So some troubleshooting tips. Service failures are printed to console.log syslog. They actually do tell you when a service has gone into maintenance. Always start debugging with services-x and check the health of your system with services-x. One of the nice things is, as I showed before, there is this message site on sun.com which shows diagnoses for the faults that we actually found on the system. And we'll be updating those with more and more information as time goes on. Services-x does display the log file, as I showed before. And sometimes the log file is not in var service log. It's in this etc service volatile, which is essentially a tempfs file system. We need to do that because, well, we use SMF to actually mount the file system, mount the var file system, and we don't have anywhere to log to until that action actually happens. boot-m verbose shows the start messages, which can kind of help. As I talked about before, you can actually debug a system that hangs during boot a lot better. Because you can boot to this non-milestone, log in, and just kind of watch the services come up. We do always try to give you a console login prompt, but that's not completely successful in all cases. So how to recover a broken service is basically, first thing is to refresh it. Make sure you've got that latest configuration, because maybe you just made some changes and you haven't picked up that latest configuration. The services-x, the message site does give pointers on how to recover the service. The other thing you can do is if you have made configuration changes that were broken, this is an example of how you can revert to a previous snapshot. So we look at the cron service, we look at the snapshots that are around. Initial is essentially when we first imported that thing at the beginning of its life. Last import is if there have been any changes, we'll have those there. Previous is essentially what the previous time that we started it. Running is what's running now. How does the service actually look on the system? Start is what's actually most interesting. That was the last successful start on the system. So you know that service started successfully with that configuration, and if you revert to that configuration, refresh it, restart it, and you'll have that configuration on your system. We've also provided some more instructions for how to recover your system if it fails early in boot in libservice share readme, which will be pointed out to you if your system is having problems early in boot. As well as the repository can be restored from backup. You'll get this reference as well as some explicit instructions if your repository is ever corrupt. But in addition, we actually have these instructions, and they're moving their way into our administrative documentation. So what's it look like to actually develop a service? Conversion is done piecemeal usually. It's done very quickly with just a few lines of XML to begin with as a lightweight app. So usually what you do is you create this service manifest, which most of us create them by copying from a previous one, which there are 120 under systems, so there's lots to pick from, and I'll show you some, I'll give you some good places to start in a minute here. You can make minimal modifications to your Etsy startup scripts and re-invoke them as the service methods. Then you import the manifest, service config, import the manifest name, you test your service, and then with your service package, you deliver the manifest and method. We're working on, as I said, service developer documentation, which gives explicit instructions on how to do this. So why bother? First, visible using standard Solaris tools. Basically, the application can be monitored using services as opposed to using some other application-specific mechanism. It's manageable as well, can be restarted and the like, and as well as will be restarted by the Solaris system if there are problems. And finally, we're developing new generic tools every day, and those will be automatically leveraged for your service if you develop it using SMF. And that's additionally what I'm talking about with the future software diagnosis. So this is the lightweight acting. The trivial way of integrating with SMF means create that manifest, just move your init scripts, reinvoke them as start methods, and then do some minimal testing to say, hey, yeah, it starts correctly, it stops correctly. I kill off a process, it comes back, hey, that looks good. Full restartability is if you want to actually break up all your daemons into separate restartable services, which gives them even more granular error handling. And then advanced is not often done, but basically you can also avoid some service restart if the fault can be internally handled. And this is usually done with sophisticated applications which basically know whether a failure is fatal to the system. So for example, a individual CGI script is not important to Apache. You don't need to restart all of Apache just because some script failed. But if the Apache daemon failed, then that's actually critical and the whole service should be restarted. So returning to this, now that we've actually talked about most of these things, what does it actually look like to develop UTempD, or a simple application service? You name the service, system utemp, which is a system because it's required for the system. Usually an administrator or ISV application is developed as app or application. Default instance means, yeah, there's usually an instance. It doesn't need to be configured by the administrator before it's run. It's just always there. Single instance means there's only one of these. Basically, more than one of these doesn't make sense to run, so don't let the framework allow it. Dependency name, so we're talking about a milestone. The system must be configured completely before UTemp starts running. We see restart on is none up there, and that means that we only require this in order to start up. We don't need to, if this thing fails later, we don't need to restart UTemp date. The dependent name is a part that we didn't actually talk about, and that's so that if something depends upon your service, you don't need to specify it in a different in the service that should have dependency. You can actually specify it as a dependent. So in this case, we want to make sure that UTemp is part of the multi-user milestone, which basically corresponds to RC2. Exec method means is the start method, and we essentially just exec this script, which looks almost entirely like the init.d script used to look before. Timeout means how long it might take. The other thing that's nice is the stop method here is the :kill, which is a keyword for SMF, which essentially means kill everything in this contract. You no longer need to keep around some crazy PID file to figure out whether what the PID of your application is in order to go send the signal. :kill just says everything in that contract, everything that's part of that service should be killed together. And then again, we went off and documented some things about our service in order to make sure that administrators could know what was going on. Our DTD, we hope, is self-documenting. It is highly commented at this point, at the very least, and can be read. It's included in all in all of our manifests on the system. You can actually go look at our manifest in var service manifest. Simple standalone daemon is UTemp, as I've already shown. Core item is a configuration service. Essentially, it doesn't leave any processes running at the end of its execution, but it does a bunch of stuff like upload the information about core files into the kernel, tell it what to do. Network telnet is an INET daemon. And INET-com can be used, basically leveraged to create service manifests. So one of the things that we're actually starting is to talk about contributed service manifests. So obviously it's best if service manifests are delivered with the service software. That is to say, it would be best if Apache service manifest was delivered with Apache. But on the other hand, free packaging sites like blastbrave.org and sunfreeware.com are great places to actually package up these manifests as well. But sometimes that's not an option. It's too much work, or perhaps you create a manifest for Oracle. So we're going to be leveraging on OpenSolaris.org a common location to deposit manifests and methods. So basically these manifests can be shared with the community easily, and you can go and look in a single place, or someone might have actually created your Oracle service or your Sybase service or something like that, even though the ISP actually hasn't gone to the effort yet. So as of next week, I'll be launching the first set of prizes for these. So if you've got a service manifest to contribute, I'll be running the contest off of my blog, and these will be the prizes. So SMS mugs, that's one of the few command line mugs. It's actually not a Solaris logo on here. It's the actual, is the quiet secret about them. And better yet, a bit of Solaris lore. Greenline was the code name for our project. It is not actually the product name or anything we use in any public literature. And I will give a mug to anybody who recognizes where this is from. Anybody know what this map is?
Oh, it is. One of the subway is Boston.
Yes, it is. It's actually the Boston subway. So.
Who am I giving one?
Raise your hand.
Yeah.
I didn't hear who got the as well. We have more mugs than that. Man, that's to determine how. Are you going to run a contest now?
Yeah, has anybody actually created an SMF manifest aside from the Sun folks? We don't care. Yeah.
Yeah, some folks don't count.
Anyone? Nope. Well, this will be your chance starting next week, as we'll be opening up the contest with prizes. So, I did want to mention that we've got a bunch of additional resources. Our big admin site is under self-healing because we are a component of self-healing, but essentially we put all of our documents there, and either later this week or beginning of next week, our developer introduction will be into a huge book, and it'll have more and more information. Yeah, Alan?
Maybe we could ask them what kind of manifest they'd like to see that they don't have today. You know, is there any software that you're using on Solaris that doesn't have a manifest today?
Anyone?
Postfix, XM? No.
Postfix? Jeez.
Databases? No?
Yeah.
Postfix. So one of the things is Postgres. Okay. That's a good one. I haven't heard that one so far.
I actually wrote one for Postgres, so.
Oh, cool.
All right, that's what's fun.
Postgres.
Yep, that's
That's a cut.
That's definitely a mug.
There's a lot of people who know have to change their network configuration every time they use.
Yes.
Right?
So one of the network configuration changes is something is the other reason that we did SMF. Basically, we put two projects together, and there was going to be a database just for networking configuration changes, but we said, you know, this should all be the same thing. Service configuration is service configuration. And the networking folks are actually working on a bunch of projects right now that include mobility as well as just simplifying network service configuration. That's a huge hurdle for a lot of people, and we recognize that and is being worked on. Yes.
What are some of the features that you're working on?
So there's definitely some of the wireless configuration stuff, just generally unifying how a lot of our network stack is configured in general, the mapping of IP addresses to their interfaces, what the interface configuration looks like, as well as bundling that all together with some of our IP-MP, our multipathing configuration, making that a lot easier to use. In addition, there are a bunch of wireless configuration tools floating around within Sun as prototype code, and I suspect they'll be escaping into the wild soon.
How does this management work when you have the zone? How do you work with this?
Fair question. So one of the things, so basically a zone is a Solaris instance as far as we're concerned, and SMF is managed within a Solaris instance. So when you create a zone, there's an entire little mini SMF running within the zone with its own set of services and the like. So those services are restarted from within the zone, the privileges from within the zone. So the root user within the zone has the ability to manage those services and enable and disable what they'd like to, obviously within the security confines of your zone.
Do you have a zone installed?
I do not at this point. It is deleted at this point.
I just reinstalled that laptop and I don't know what to do.
My only bug is someone else is going to have a...
Well, I just did it last night, okay? I haven't stopped there yet. Go ahead.
All right.
The other thing is Stephen Hahn and I are blogging more or less extensively on SMF. And in addition to our big admin site, it is the locus for information in addition to community information on SMF. With OpenSolaris, there will be an SMF community. It's coming. It's for those in the pilot program. It's there with the next version of the website, and it will be there on our launch. We're definitely interested. It is wholly Solaris owned technology. We created this thing out of whole cloth in Solaris 10. We own it 100%, and much like eTrace, we believe in getting it open, getting it out there. And one of the first places we really do see contributions is in the manifest area, just kind of sharing what people have been writing in-house and provide a common location in order to provide that information. So, questions?
Is there an audit log for the service admin command so we can trace who disables, enables?
That's a good question, and not yet is the answer, and it's one of the big features we're working on soon. Essentially, right now, what we have is a log file, which tells you when these things happen, but it doesn't tell you necessarily who did them, and that is coming. Yes? Any other questions?
How would you handle the following situation? You have an automotive running, you have Oracle running.
Mm-hmm.
Oracle depends on the auto-mounted data directories. So usually you want Oracle to depend on auto-mounted, so the auto-mounted starts first, and Oracle starts to shut down. Oracle starts down first, auto-mounted shuts down after that.
Mm-hmm.
But there might be a situation when the auto-mounted gets confused, and you want to restart the auto-mounted without restarting Oracle. Is there a way to model that?
Yeah, definitely. So we talked about those restart on here. This is ridiculous. If I move this further away, that'll help. Better? Okay. Essentially, what you can do is the restart on, you can essentially say if the automator has an error, Oracle will be restarted. That's the restart on error dependency. Whereas the restart on restart, which is usually an administrative operation, you type service admin restart because the automator was confused and you wanted to restart it, you actually don't need to restart it then. So you basically specify your Oracle dependency as restart on error of the automator, not on anything else. And there's more that, obviously, we don't communicate everything that goes wrong with the automator as errors today, but we'll be doing more and more in the future. The model does provide it, but...
Would that also be a place where you want to have a file dependency because you're waiting for a certain NFS amount of path to show up, or is that?
Not so much.
Okay.
We did make some errors in our model earlier. We have file dependencies, which I don't recommend using today because they're we don't have file monitoring in Solaris in general at this point, so we don't detect whether these files come back up after if these files appear, essentially. So I can try to show. You had something else?
Did you want the laptop to demo the Kill 1? No, you don't?
What about feedback? Any feedback from you guys that are using SMF? I mean, do you like it? Would you like to see something else?
It's about frickin' time.
What's that?
It's about frickin' time. 30 years was too long.
Yeah. Thank you. I think you had a question though?
I was curious, why do you leverage SQLite but not include the userland tools? Or did you hide the userland tools?
We do ship the SQLite binary that's right next to config, but it's not a public interface that we want people to be going off and...
What is it named?
Lib service bin SQLite, but it's not a public interface. We're not supporting that as... We support you using the API, the libscf API to talk to the repository, working around with it directly.
No, I just mean because in a lot of cases where people are using SQLite elsewhere, it seems kind of redundant to install a separate instance of...
So the RFE is you want SQLite as a general system service. In other words, user bin, or user lib SQLite or something like that, whatever it's called.
Yeah.
Okay. So it's sort of a...
Since it's already there.
Okay, yeah.
That's a fair RFP. So what Brian's shown here is basically he's booted zone Tweedledee. And here we have, I'm going to do this now. And basically, within the Tweedledee zone, we have a set of services, including some offline NFS and printing services. But essentially, you have a set of services within the Tweedledee zone, and these are only visible from within the Tweedledee zone. Or more specifically, they won't be visible from within other zones. It's essentially all of SMF within Tweedledee. So the auto mounter is running here as process 833, whereas here if we do, we have a different PID that's in the global zone, and that's the global zone version of the auto mounter. So essentially, it looks just the same to you. The goal of a zone looks like a mini Solaris system. Obviously, if you're savvy, you can tell it's a zone, but you don't have to know it's a zone in order to do administration of it.
We look at the data in that local zone and just see what.
How quick it is?
How quick is it? Just how few
the other thing
you see out of a shape and weights.
The other thing worth noting is that if you're feeling a little sort of apprehensive about getting to know SMF, make a zone and screw around with it in there, because if you totally zort your system, you can always just nuke the zone and create it again. Or you can practice well, what happens if I damage the system? Right? What happens if I move Etsy BFS tab out of the way and I reboot the zone? It's like that's a great way to practice that and still be able to recover, to know how to be able to basically analyze what's going on. It's kind of a low-risk way to mess with it.
So the nice thing about it, you can actually look at here, is there's the rebooted by boot message at 210917, and it took me a few seconds to log in, so unfortunately, it's only a 15 seconds to the next time that I actually looked at the timestamp. It's really quick, it's really easy to actually play with this stuff, and it's actually how most of us do development on user line components now.
The other thing we're doing is run a PR stat minus cap Z in the global zone, and then reboot the local zone, and see how much faster you see the login versus the CPU utilization. So now go back to that PR stat.
And essentially you see
And now you still see the CPU time high, even though you got the login prompt there, because all your services are still starting up.
those are essentially, so what's really fun is you can actually also look at
Maybe we need a NewBoot zones.
Sorry.
Yeah. Actually, this is great. Console login is actually at the top there. We start console login as early as is humanly possible, because what's console login good for except for to log into your system to fix it if something's going wrong? So we really try to give it to you as early as possible. And there's all this stuff that essentially starts up after console login running, because there's no dependency relationship between them. Yeah?
-9 -1. Good work.
I just killed it.
Yeah, you're right. Would you ever want to use just kill? And it's restarting. Start these restarting.
So something Liane didn't mention but was on her slides is init actually will restart if it's got some poor luck to die in S10, and it knows how to recover its state and snapshot its state to the file.
Start these six. That's cool.
In June, David Comey is going to be speaking on zones.
That's fun.
We're getting there.
We're getting there.
Very simple graphic indication, graphic interface.
Not at this point. What are you interested in a graphic interface?
Like TK Wellness plug-in module. I'm on create little indication of red, green, yellow.
So lots of people.
When an event happens, something happened. I don't care, what it is.
That's just what to do from there. And you could do it in Perl pretty easily, I think.
Yeah, you can get it's just a polling mechanism as opposed to an event-based mechanism, and we do recognize the need for an event-based one. But yeah, definitely a lot of people have written similar tools today, which just go off and say, "Hey, is everything okay? Hey, is everything okay? Hey, is everything okay?"
And the other thing is that some people would have might have a lower threshold as to what they would consider to be a red alarm. And that's one of the reasons why an all-encompassing software tool is probably not as effective as an in-house written Perl script, because you can set your own threshold. What is a green alarm? What is orange? What is red? So on.
And that's why we want to provide essentially a framework to do what makes sense for your organization. If it's an SNMP track or a shell script, which basically has your organization's guts in it to say, this is critical. Send mail going offline, not a big deal on this one, send a mail to somebody. But Oracle going offline, huge deal, red alarms, pages to everybody, right? We definitely want to allow that flexibility. Not yet. It's definitely high on our list of things to do.
One other thing is to take a look at the code in Big Brother, because Big Brother does a certain amount of color-coded alarming. By looking at how Big Brother makes its decisions, that would give you a few hints as to what to do with Perl.
There's a question coming?
Yeah, question. Could you highlight again the advantages for somebody writing a new service or a conversion? I think I heard one, for example, is we can take advantage of the restart mechanisms and then fault detection that SMF provides.
Yep.
What about logging? Does it capture anything written to?
Captures all standard out and standard error into the var service log file for service.start demanaged services.
That's separated out from everybody else's messages?
It is, absolutely. Yep. It is. It's basically in, if you see it in a var service log, you see a bunch of different, there's a file per service essentially, and it's really simple and really straightforward. It's just we just redirected standard out and standard error for those sets of processes, unless if they do their own redirection. So obviously some processes will close that, but if you're doing service development and you just want simple logging, this is a great place to do it.
The other advantage you mentioned was PID, process ID management.
Yeah, you basically don't need your PID files anymore. So a lot of services had a stop script that essentially did nothing but read this PID file, kill this PID, right? That's actually no longer necessary with that : kill, because we know what processes through this contract mechanism are associated with a service. We can essentially say, we can use the : kill to say, send a signal to every constituent of this contract.
And if the process dies, then SNF will detect that it dies.
Absolutely. That's the kind of the built-in restart. So a process can die for any number of reasons, and that's a really critical point. There's the admin, there's your software bug, but a process can die because there was a hardware error that Solaris detected and couldn't completely correct. So what SMF allows is us to do restart if there are, basically no fault of your own, no fault of the admin. The process just goes away, and SMF now can detect that, and you don't have to restart the entire system to figure out what's gone wrong, which is what we used to do in previous releases. Essentially now we do the restart much more granularly, and your application can take advantage of this by converting to SMF.
I would also say that, so I run some servers for us at Sun, and I would also say that, for example, I run a web proxy, right? And so I went off and wrote a manifest for Squid, and one of the things that I find that's nice about it is it's very easy for me to know, is Squid working the way I expect it to be working? And, if it dumps core, which it really likes to do late at night, it will automatically restart. And it's like, it just means that I don't have users complaining at me nearly as often as before. And when it does restart, or when it is experiencing a problem, it's much easier for me to know, is it Squid that's the problem, or has the name service experiencing a problem, or some other component of the system experiencing a problem, right? For me, it's like, what I find with a lot of systems, when you approach them to try to go, well, I've got to I'm a system administrator or whatever, I'm trying to diagnose what's wrong with the system. And a lot of times you get the call, and the call is, well, the web server's not working, right? But the real problem isn't the web server's fine. And the real problem is that name services on the box are broken, and so, or some subsidiary problem exists on the machine. And so when Liane was showing services minus X, what that does is that automates that process of walking the graph of services on the system and seeking the root cause problem. Right? Services minus X doesn't tell you the web server's broken. Services minus X tells you the thing that the web server depends upon that's broken. Right? So that way you don't focus your effort on debugging the web server when there's nothing wrong with it. So that's why I personally like it. For managing my services. So I've been really happy with it on our web hop, which is our web proxy.
So. Are there fail-safe mechanisms that avoid having to restart a service basically will never be started.
Yeah, so one of the things that we definitely have is rate limiting, where if it's basically failing every second for 10 seconds, that thing's sick. Putting in maintenance. It's not configurable right now, but that catches 99% of the cases because most things really die rapidly. We're looking at how to make it configurable in the future, but essentially, INetD still has its rate limiting, so that if it's dying too quickly, their services don't keep getting restarted. But StartD also has some thresholds built in.
The other question that I have is, are you going to expose Java APIs?
We're working on it. No schedule yet, but it's because we want them to build on top of. We're also, and are there any other APIs we want? Right now, it's essentially we've got a C library and we've got a shell scripting a language which is with service prop. Are there other things people want? Any other language bindings aside from Java? Perl? Yeah. Cool. Any other questions? Cool. Well, thanks, guys, and hopefully you guys will want to stick around, talk to some of us. There are lots and lots of Solaris folks here. There are people who know plenty of stuff about Open. I saw Simon Phipps back there, who's on the community advisory board for OpenSolaris. And I hope you'll attend some of these in the future. I mean, if you didn't find me interesting, maybe you'll find somebody else interesting. We've got a whole range of things to talk about with Solaris, and I actually think this is going to be really valuable to finally have a place to come talk to you guys in person, and you can give us feedback too, and we really appreciate it. So, Open's coming, and to all of you, if you're a Solaris fan, just blog about it. Tell us what you love, tell us what you hate, tell us on your blog. I mean, it's really easy to create them today. We love them, and we're happy, with people who want to create them, and we'd love to hear from more of you too, what you like, what you hate. We actually do read it. It's a great place to communicate with us as well. So. Thanks, guys.
I have some T-shirts, and I like to give them away to the non-Sun people first. but we actually might have enough for Sun people also. So if you guys want to come up, and we'll give you a T-shirt.
Oh, this is all great. Yeah, I'm running out of
How's it going, Simon?
Feeding frenzy.
Yep.
Do you want me to get you one?
Oh, I'll get one.
Yeah, well, we know you don't work for Sun. And you look like an elf, so. Got rid of another CD kit.
Yeah.
These are all elves.
Small library.
There are some games. Yeah, and I don't know what size you wear, Al?
Hey, they're in black finally. That's fine.
We have a lot of
Thanks.
You should have No, I don't exercise a lot. Well, I have.
Alan, do you have enough for Sun employees?
I believe we do, Brian.
Are they all extra?
No. For you?
If you're large.
Not until he does another D-Trace demo, so we can harass. I've done enough D-Trace demos for my dinner.
No, he has. So we can harass. Brian has earned his shirt. Brian has earned a wardrobe, probably.
Medium. Oh, good. Oh, nice. Very nice.
Oh, the classic.
I still kind of like the nice class.
XL screens and lots larger.
Large?
So I'll be watching.